Hello, everyone. My name is Samia Ashraf. I am a Flutter engineer, a Google developer expert for Flutter and Dart. And today I will be talking about a very interesting topic in Flutter, which is called secure storage, auth, and encryption in Flutter apps. Now, this is a very essential topic because in at some point in time when you will be working with larger applications or even smaller applications, you will be working on the security part of it, and that is where you will be applying these things that we learn today. So let us discuss our agenda for today. So I'll be talking about the importance of security, why we should have security in our Flutter applications, followed by obfuscation, which is a kind of a security practice to prevent hackers from reverse engineering our application. Also, we will be discussing different types of data storage in Flutter, which is secure storage and shared preferences, followed by some of the authentication techniques that we have in Flutter. We will also discuss how we can handle tokens and session management, which again comes under security. Then we will discuss one of the types of encryption methods, which is AES, using the AES algorithm. And finally, we will discuss security mistakes that we all do and how we can avoid them. And we will also discuss some of the best practices. So let us begin with the importance of security. Now, to understand why we need security in our application, you need to know its importance and what can happen if we negotiate in terms of security with our application. Now, you will agree with me that almost everything in today's world is digital. Compared to the last decade or even the last 5 years, we have gone digital in so many ways, in so many fields. Let it be healthcare, or we have our digital wallets in the fintech sector, or so many things. Even we have so many options of crypto trading in today's world, and they are all heavily dependent in the mobile devices, which means that our mobile devices handle sensitive data. And when mobile devices handle sensitive data, there needs to be a proper security measure to prevent our sensitive data from being exposed. Flutter is cross platform, which means that the security must be consistent in all of the platforms that we work with, may it be Android or iOS or Windows. Any platform that you work with needs to be very tight in security. And also, data breaches are very costly, which means that if you negotiate in terms of security with your Flutter application, it can be a high loss for you, because that would mean negotiating with your customers' sensitive information, which is not good, and that can come with a lot of consequences. So, whether you're building a banking app or a healthcare platform, or even just having um, any kind of a small app that has user management or user sessions, that needs security. So, any kind of sensitive data, if your app handles any kind of sensitive data, then we as developers, it is our responsibility to secure that sensitive data from being exposed. Now, there are different measures on how we can do this, and we will discuss them one by one. Now, uh, when we talk about security in banking app, now this has to be a top priority, because when we work with the so so let's say we are having a banking app. Now, any kind of data inside can be uh, it can be like it can have a lot of consequences if it's exposed, not just the user profile. It can be even the user's details, or even users financial details. All of this needs to be handled with extreme care, because we're talking about banking apps here. And even healthcare platform, it also has a lot of sensitive data, like your users records, their health records, and all sorts of sensitive data is also there. Now let's say I'm working on a gaming app. Now, of course, the financial part of the user is considered sensitive data. But when we talk about just the users in my gaming app, I wouldn't say that that is of very high security, because we will be knowing, right, who are all the players in the game. And yeah, so this is the difference there. Now, let's discuss about what obfuscation means. Now, obfuscation is the process of making your code hard to understand. Now, we are working on a very big application, and and we want to apply all kinds of security measures to this application. Obfuscation is a type of security measure where you are going to alter your code in such a way that all the classes, the methods, uh, will be the names of the classes and methods will be altered. So I have a sample diagram here to make you understand better. Now, a non-obfuscated code, which means code without any security measure, is going to look like this: auth manager or login. And as we all know, auth manager would have functions and variables for an authentication manager, like login and all that. When you look at it, you get an idea of what could be inside the class, right? Even the login function, in very simple words, I'm sure it will perform a login functionality. Now, when I apply obfuscation to this, to my code, which has auth manager and login, it is going to look somewhat like this: underscore A and B. Now, the purpose of doing this is that when I have my code, and if anybody gets their hand on my source code, then they will have the power to reverse engineer my source code, which means they will at some point be able to run my program, which is a huge data breach, but also it is possible. So, what I can do is I can apply the obfuscation and make the code in such a format that it is very hard to understand, hard to even read, and very difficult to reverse engineer it. And also, um, unauthorized users will not have access to my code, unauthorized persons. So that is what obfuscation means. You're deliberately making your code hard to understand or analyze, difficult to read, and impossible to reverse engineer it. Now, how can we do that? So renaming classes. So when I apply the um, obfuscation technique, what will happen is that my classes will be renamed, methods will be renamed, and even the variables will be renamed. Login can become something like A or underscore A, which is really meaningless and does not mean anything. So, making it difficult for someone to decompile the app, to understand the original logic, or steal sensitive implementations. This will also make them difficult to reverse engineer it. And also, even if they manage to reverse engineer, which is very unlikely, it will be difficult for them to understand what exactly is happening in the application, and they will not be able to access your sensitive functionalities or implementations that you have done. Now, how can we achieve obfuscation? One of the ways that we can we can apply obfuscation in Flutter is in Android. We can use the hyphen hyphen obfuscate flag, which means that build an APK in debug and obfuscate my source code, so that at any point in time, if anybody gets hands on this APK, they will not have they will not be able to reverse engineer it. So that is what this means. Any build commands that you use, just add the obfuscate flag, and that should compile and build a source code with the obfuscate data. And in iOS, it would be the same, the obfuscate flag with a hyphen hyphen and split debug info. So let's see how we can do that in release. Now Flutter build app bundle, again hyphen hyphen obfuscate and split debug info. And even in the release, the only thing that we're going to replace is from debug. In the debug, we have the debug flag, whereas in iOS, we're going to add the hyphen hyphen release flag, split debug info, build hyphen debug info. Now let's see what this exactly means. What do the flags do there? Now, obfuscate obviously means it will obfuscate your Flutter project. The Dart code inside will be obfuscated, and split debug info means that it will save a symbol map to deobfuscate the stack traces later. So you can also deobfuscate the source code that has been built, and it is going to save the obfuscated source code the in the path that we give here, which in this case is build hyphen debug info. Now that was about obfuscation in Flutter. Let's see how we can store data in Flutter. Secure storage is one of the types of data storage that we have. And secure storage protects sensitive data like your access token and refresh tokens, your pins, the passwords, the biometric or session flags. Which means if the user is having a biometric login method, then have uh, we're going to have a key that is going to tell if the user has set biometric login to true or false. So that can be such things can be stored in secure storage. And it is also important to understand that not everything should go inside secure storage. The word itself means it is a storage system to store secure data. So if we have something like the user mobile, because user mobile is going to stay consistent throughout the application, such things should not go in secure storage. Such things we can have different kind of data storage for that, but not secure storage. So it is only meant to store sensitive data that cannot be exposed. So our mobile number is something that is going to be seen in the application, right? So that cannot be considered as sensitive data. So yeah, our access tokens, refresh tokens, these are something which are not going to be displayed in the application. That can be considered as sensitive data. Even our pins and passwords, and also the session flags. Now, secure storage in Flutter can be achieved by using the Flutter underscore secure underscore storage package, and always try using the most recent version of this. And what Flutter secure storage does is it is not going to store the data as it is. Now let's say I have my password set to 0000 or my pin. Now, Flutter Secure Storage is not going to store my PIN as 0000. It is going to do some encryption methods. And using these encryption, which is native specific, for iOS we have the keychain, and for Android we have encrypted shared preference or key store method. Using this encryption technique, my PIN is going to be encrypted and stored in the Flutter Secure Storage. So this is very important because uh, variables or data like name, mobile number, such things do not need to be encrypted and stored. So it is very important to understand the difference between sensitive data that needs to go in secure storage and other data that can be stored otherwise. And the reason for that is because secure storage uses encryption, it is a little performance heavy, not in wider terms, but just to make you understand that uh, there is a certain performance delay when we are using secure storage because of the encryption decryption the method that happens, because the secure storage stores it as encrypted data. Obviously, when it needs to be accessed, it needs to be decrypted. So that there is um, a certain work that is happening. So that is the reason it is little expensive when compared to other data storages, and it should be used wisely. So how can we achieve or how can we use secure storage in Flutter? So we're going to have a secure Flutter secure storage object. And using this object, we are going to write, read, and delete our keys. So let's say I have my auth token, which is ABC123. I'm going to use the object and its dot write method, store the value ABC123 in the key auth token. And throughout my application, I can access this value using the key. So your key needs to be unique. I cannot have two keys with the same name. I cannot have auth token twice because it doesn't make sense. Auth token should be stored only once, and we cannot use the same key to rewrite something. So yeah, so that is how we can write the data into the secure storage. So after writing, we're obviously going to be reading it somewhere in our application. And like I said, my value is going to be it can be accessed throughout the application using this key, which is auth underscore token. So I'll just say storage dot read and the key. So it is going to go into the secure storage and find the auth token, and it's going to decrypt and give me the value in token, which is a string. And another thing that we need to understand here is that because there is an operation happening here, the decryption and finding the key, we are going to use the await to wait for the decryption to finish before we move on to the next line. That is the reason we have the await there. And notice that I have made this variable nullable because I can try to read something which does not exist in the secure storage. So such things can also happen. Maybe I have by mistake entered a wrong key. In such cases, we are going to have the token as null. Otherwise, it is going to store the proper value here. Now, if I want to delete my token, then I'm just going to use the storage.delete and the key that I want to delete. In this case, that is auth token. And again, it's an await function. So this is the three simple functions that we have in secure storage: the write, read, and delete. Moving on, let's move on to our next type of data storage in Flutter, which is the shared preferences, which I'm sure most of you have heard of or even used. Now, the difference between secure storage and shared preference is that secure storage stores sensitive data using the encryption decryption method, but shared preference is going to store the data as it is. So, I said that data like your name, your mobile number, it's not very sensitive within the application. So, for such data, what we can do is we can use the shared preference, and shared preference is going to store my name as it is. So, this is the difference between secure storage and shared preference. Now, my login credentials can be considered as data that can go into shared preference. Even tokens or personal data like my name, mobile number. Now, using shared preference isn't enough. It just stores the data in plain text. Now, login credentials, when we talk about login credentials, we are talking about access token and even the encryption keys. Now, these are something that we should not store in shared preferences. This should go in our secure storage. But personal data like our mobile number or name, address, so these are things that you can store it in secure storage, but we can also store it in shared preferences also. Now, so such kind of data, which is the login credentials, tokens, and everything, we are going to store that in secure storage, which will also give us platform level security. Now, this kind of data should not go in shared preferences. What is the kind of data that should go? It can be like the user data. So, yeah, having these stored in Flutter Secure Storage will make sure that our sensitive data is encrypted and it is only accessible in the app and not displayed in different parts of the screens. So, let us understand the difference between secure storage and shared preference feature wise. Now, like I said, shared preference is used to store simple, non sensitive key value pairs. And this is something that we need to decide what can go in secure storage and what can go in shared preference. And storing sensitive data like tokens, password, etc., should go in secure storage. Now, there is no encryption happening in shared preferences, but in secure storage, we have encryption because of which it is considered as the storage system for sensitive data. And where is our data going to be stored? In shared preference, it's going to be stored in an XML file that is stored in our app's internal storage, which the reason for that is so that it is not easier to be accessed. And in secure storage, it will be stored in iOS keychain or the Android key store. Now, when we talk about vulnerabilities in shared preference, um, the data can be read if the device is rooted or jailbroken. Jailbroken devices are those where the OS of the device has been hampered, which means when we have a mobile device, the operating system of that device has been malfunctioned in a way that the hacker has introduced their own OS into the mobile device. And what happens is that when you run your application in jailbroken or rooted devices, it becomes easier for the hacker to get access to the internal files of our application. So in shared preference, the data can be read because it is stored in the app's internal storage. So the hacker, when they are working with the rooted or jailbroken devices, they will have access to the files, the different files of our application. But in secure storage, that is not the case. It is much harder to access because the security comes from OS level. Now, one more thing to understand is that if we do not want such things to happen, when we are writing or when we are building our Flutter project, we need to write platform code to prevent our app from being installed in rooted and jailbroken devices. And we have commands for that. That is again very important to maintain security in our application, not to be installed. If you identify a jailbroken or rooted device, immediately exit the application. That is what we can write. And in terms of data persistent, persists across app restart, and in secure storage, persists securely across restarts, even device reboots, which means that once the app is restarted, the data is lost from shared preferences. But in secure storage, even if the device reboots, we still have access to the secure storage data. That is what this means. And the plugins that we use is shared underscore preferences for shared preference and Flutter secure storage for secure storage. It is very important to understand the difference between what data should go in shared preference and what data should go in secure storage. And it is also important to understand that not all data should go in secure storage. So, to identify the difference between sensitive and non sensitive data is something that we need to take time and differentiate, because if we store everything in secure storage, it will have a negative impact on our application because of the encryption decryption that is happening to read and write the data. So, now let us discuss some of the authentication techniques in our application. And why do we need authentication technique is because let's say I'm trying to access an API, and let's say this is get profile information now of user one. So let's say I'm trying to access an API of where I'm trying to access the profile information for user ID 1. Now, if I don't have a kind of token or something, then anybody can access the profile information for user ID 1, right? So there needs to be some kind of a token that is being passed to verify if the user is authorized to read the information for user ID 1. These kind of tokens are mostly JWT tokens or JSON Web tokens that are being sent with the APIs to the server to for the token based authentication, which means using this token, I'm going to decide, the server is going to decide whether you can access the profile information for user ID 1 or not. And also, this is the most commonly used web token. Now, where do we get this token from? This token comes from the backend the moment you log in. So let's say I'm user ID 1 and I have my PIN 0000 and I log in. So when I log in, I'm going to get um, my token, access token, and this access token I'm going to securely store in my Flutter secure storage, because I will need this token to call the APIs from to call any kind of API from the server. And now let's say I'm trying to access profile information for user ID 1. I am user ID 1. So when I send the token with me, server is going to decide that okay, this is the user and they are trying to access their information. And that's how I'm going to get the data back from the server. And yes, token is stored securely in Flutter secure storage. This is the most common type of the authentication technique that we currently have. Of course, there are others, but this is the most common one here. And let's say I'm trying to access the profile information, that is all the kind of sensitive data in that profile for user 2. And let's say I'm not authorized to view the data for user 2. So when I log in with user ID 1 and pin 0000 with my access token, the server is going to send a negative response saying user is not authorized to view the data. So based on this token, it's going to decide if the authentication is valid or not. Now, the security practices for using JWT, JSON Web Token, is we are going to use access and refresh tokens and store the access tokens temporarily and rotate tokens periodically. And what this means is that, let's say by any chance, by some chance, the access token has been leaked. So what happens is that anybody who has this access token can now view your data, which is not good, because that would mean your data is now exposed, and that should never happen. But to prevent that from happening, what we do is we use refresh tokens. Now, what does refresh token do? So every app will have a set limit for the validity of an access token, and this limit is set by the backend. And so let's say my access token is valid for 10 minutes. So what happens after 10 minutes? My access token is going to expire. So there is something called refresh token, which again comes with the login. And this refresh token can be used to generate a new access token. So I have my access token and I have my refresh token from login. Access token is what I will be using to access different APIs. After 10 minutes, my access token cannot be used to access any API. What do? I use the refresh token. Using this refresh token, I'm going to call the validate API, where I will be given a new generated access token. So this new access token is what I will be using to access the APIs. So this is again very important to understand the difference between access and refresh tokens. And honestly, this is something that you will understand and get better with practice. And I highly recommend you to try different examples for this. There are many sample projects in Google that will help you to play around with access and refresh tokens to understand. And it is also important to rotate the tokens periodically, which means do not stick to the same access token for a very long time. For some applications, this can be 15 minutes. Other applications, this can be 1 hour or 1 week, 1 day, 1 week. It depends from application to application. Most banking applications will have this set to 10 or 15 minutes, because and how you can why so one example what I can give you is, I have my banking app and I have logged into the app. Now let's say the app is now sitting in the background, I'm not going to use it anymore. So after a while, when I come back, let's say if I come back after 6 hours, and you will not see that the application is still running. The application will already have you logged out, because the access token is has expired. That is the reason you are logged out from the application. And expire the tokens on logout. Of course, when you log out, all of the sensitive data needs to be deleted. That is because when, let's say, a new user logs in, then your anything that is in your secure storage needs to be deleted, because remember, secure storage data will not be deleted until you delete it. Even if you remove even if the device reboots, it will the secure storage data will still be valid. That is the reason when you log out, you need to delete all of the secure storage data. Shared preference data we do not need to delete because it will be automatically deleted. Now, other type of authentication, a very common one that we see nowadays in most applications, is the biometric authentication. In biometric authentication, we do not have to enter the password. So, what can replace the password? It is the Face ID of the user. Biometric authentication will authenticate the users in the application using the Face ID or the fingerprint. And this is a device level security that we currently have. And the package that we use, the plugin that we use is local underscore auth. So if you want to integrate biometric authentication in your application, we'll be using the local underscore auth plugin to implement that. The implementation is very simple, and and it is device specific. So for Android, we will have the touch, the fingerprint security, and also the face ID. Even for iOS, it's mostly going to be face ID, but in the older versions of iOS, iPhone, we still have fingerprint security there. So the security practices for using a biometric auth is always fall back to PIN and passcode. Combine it with the secure token validation. Now you might be wondering, how can the Face ID validate a user into the application? Now, when the Face ID is validated, so what happens is that now the Flutter application knows that this is it's the current user, it's the authorized user, and what the application does is once it receives the signal that the authorized user has authenticated themselves using biometrics, then we are going to pick the pin from the secure storage and log the user in. So that is how it works. The third type of technique is the refresh token implementation. Short-lived access tokens needs to be refreshed periodically and securely. The only way to do it is using the refresh tokens. And obviously, the access tokens in the memory will be stored in secure storage. And when it expires, we are going to use the refresh token to fetch a new access token. So we have three types of authentication techniques: the JWT, which is the JSON Web Token. Then we have the biometric authentication. And the third one we have is the refresh token implementation. The best practice is to never store refresh token in the memory, because your refresh token can be used. Let's say access token has been exposed, that will be anyways replaced with a new access token. But if the refresh token has been exposed, then using this refresh token, the hacker can generate a new access token and have access to all of the data. So you should always invalidate the refresh tokens after logout and store them securely in the secure storage and never in shared preferences. So next we have encryption. So how we can encrypt our data in Flutter. So, like I said, secure storage uses encryption, right? So, what exactly is encryption is we are having, let's say, for example, my PIN is 0000, And before it goes into the secure storage, it will be encrypted using different algorithms. So here we'll be discussing about the AES algorithm. AES algorithm will be applied to convert this pin into a encrypted object. So it looks something like this. We are going to use the um, encrypt plugin, a package to encrypt the data. And where can we use this is, let's say, previously I said that we will be storing the user sensitive data, like let's say the passwords. So before the passwords go into the storage, we are going to apply an encryption method. So let's say I'm using shared preferences here. I do not want to store the password just as it is. I will first apply the encryption and then store it in secure storage, so that even if anybody accesses the encrypted password object, they cannot do anything with it. So the way I would do it is use the encrypt package, and the from UTF-8 is where I will be entering my secure key. So to encrypt a variable, we are going to need the secure key and the length. So once I have my key and the IV, which is the length that I need to set, I can then encrypt and decrypt my data. So this algorithm needs two things. It needs a key and it needs an IV. Now this key is again, this is something that needs to go in the secure storage, because using this key I can easily decrypt the data also, because if you see, final encrypted equal to encryptor, which is the object, dot encrypt, you're going to apply the IV, and using the same thing I can decrypt also. So it is very important to store this in secure storage, and no one should have access to this, because then there is no point of encryption if the key and IV are accessible. So this adds a critical layer of protection, because obviously with the encrypted objects there is not much that you can do. When storing the data locally on the device, this is what we should be doing. So, I said previously that it is important to understand what needs to go in secure storage and what needs to go in shared preference. So, this is our way of imitating the secure storage, that is, taking the data, encrypting it, and then storing it in shared preference. And what happens is that one thing is that the memory here will be saved, because when the user logs out or when the app gets deleted, the data is anyways going to go away, because shared preference does not store the data in the device. It deletes the data when the user logs out. So let's say I'm storing the data in the device, which is my password, and or sending it over to the network. Then what should happen is, you cannot send the data just as it. In my even in my APIs, when the user is logging in, there is a user ID and there is a password, right? So you cannot send, and it is this is a post method, because I'm having my user credentials. So I cannot just send the data as it is. That would then become easier for the hackers to get access to my data. So I will first encrypt it, that means convert it into encrypted objects, and then send, so that even if they get access to this data, there is not much that they can do with it. So never hard code your keys in the source code, always encrypt them and then store it. And with packages like encrypt, we can implement the AES encryption, which is widely adopted and strong. So this is the common type of encryption that we have in Flutter. And I would highly recommend you to go through this if you are working with any kind of application, really. Now, lastly, let us discuss some of the common security mistakes that we all do and how we can prevent them, and also the best practices of security in Flutter. Always get a good understanding of how to properly use access token. Now, access token must be short lived and it must be stored securely using Flutter secure storage, and refresh token is used only to get the new access token. Now you cannot use the refresh token to access API information like profile information. I cannot use refresh token. The only purpose of refresh token is to generate a new access token. That is all that it does. And yeah. So biometric prompt adds an extra layer of protection before navigating to the app, which means if I have my device, nobody else will be able to access my device when I add biometric authentication. So it is a kind of an extra layer of protection. And on logout, it is very important to delete all the data that you have stored in the storage, all the tokens. If you're using any other uh, things, then we need to delete all of them. Otherwise they are going to remain there and it will cause issues when the next person is logging in, or if a different person is logging in. So it is very important to get rid of all secure storage um, tokens and invalidate them before logging out. So that is all for today. And I hope you've learned something from this session. And please add uh, uh, research on this more and add security in any application that you work with. Doesn't always have to be Flutter, it can be anything. And yeah, if you have any questions, you can ask me, and you can always reach out to me for such insightful topics. These are my socials. Any questions? So I don't see any questions. You can ask me anything. It doesn't just have to be the security topic in Flutter. Any Flutter related questions, I'm happy to answer. Thank you, everyone, and see you in the next session.